Hi, I'm Professor Goins. In this video, I'm going to look at the technique called completing the square. This is something that you will use in pre-calc, Calc 1, Calc 2, Calc 3, differential equations, you name it. This is used all over the place. This is an extremely useful, extremely important technique. So, starting point. For a quadratic function, there are two primary forms for writing the equation, or the expression for the function. We've got general form and standard form. Keep in mind that some authors, some textbooks will interchange those. For me, general form is written like this. Standard form, which is also sometimes called vertex form, is written like this. So, conversion techniques between the two. If I want to go from standard form to general form, so if I want to go from standard to general, we will use the FOIL technique. In other words, I will multiply this out, combine like terms. So that's the straightforward way to go from standard to general, just multiply it out. If I want to go in the other direction, if I want to go from a general form to a standard form, that's where, so general to standard, that's where we're going to use the technique called completing the square, which is what I will introduce over here. We'll do a variety of examples to kind of show you what can happen depending on what these numbers are. Here's the starting point. So for part A, f of x, x squared plus 8x minus 3. Here's the solution for A. What you're going to do is you start by writing the first two terms of the function expression. So x squared plus 8x. I'm going to leave a large amount of space and put the minus 3 on the end. What I do is I'm going to introduce a couple of new terms in here. I'm going to add and subtract the same number. And the number that I add and subtract, first and foremost, has the following form. I'm going to add a number over 2 squared. I'm going to subtract the same thing, so this would equal 0, which keeps the expression balanced. And the way that I find the numerator is always the coefficient of x, meaning that I'm going to put 8 on top here. All right. Then what I do is I combine the first 3 terms, and we will factor that. Then we will combine the last 2 terms, and we will evaluate. Let's see how this plays out. 8 over 2 is 4. 4 squared is 16. That gives me x squared plus 8x plus 16. This would also be 16 with a minus in front, so minus 16 minus 3. Again, we're going to factor the first 3 terms. If I put my parentheses in here to see if we can factor that, and then I'll evaluate the last 2. So minus 16 and minus 3 would give you a minus 19. And then I'm going to put in x and x here. Remember, what we need to factor this is 2 integers that multiply to get 16 and add to get 8. Okay, so multiply to get 16, add to get 8. That would be 4 and 4. Notice that that would then be x plus 4 quantity squared minus 19, and that is standard form. This function right here, x squared plus 8x minus 3, is the general form for that quadratic. X plus 4 squared minus 19 is the standard form for that quadratic. All right, let's work through a variety of examples of this, but what we can do is we can make this work a little bit more efficient. Okay, there's only, what, 1, 2, 3, 4 steps there, but we can actually eliminate the middle 2. If you notice something, after I put these in, I know I'm going to evaluate that so we can compute that and just kind of write the answer. For this one here, we evaluated this and we figured out how to factor. But going from these 3 terms to this term at the end here is actually pretty quick, because notice that the number I have here is a 4. Where's the first place in the work up above that we would have noticed that was going to end up being a 4? Well, way up here. So whatever this number is in these parentheses is the number that I'm going to put in these parentheses. 8 over 2 is 4, so I know I'm going to put a 4 there. In the next examples, let's use that shortcut. Part B, let's say I've got f of x is equal to x squared plus, let's do 10x minus 15. All right, solution for B. All right, write the first two terms. Then I know I'm going to add in these red terms here. I take the number that's in front of x, so in other words, the coefficient of x. I divide it by 2. I square it. I then subtract the same number. All right, and then we're going to combine the first 3 terms and factor, evaluate the last 2 terms. Remember over here, when I took those first 3 terms, it factored into a perfect square, where the number that was this in this circled spot right here is the same thing that I had up here, so it's just half the coefficient of x. That means those first 3 terms are going to factor as x plus 5 squared. And then to evaluate the last 2 values, 10 over 2 is 5, 5 squared is 25, minus 25 minus 15 would give you minus 40. Okay. Let's try a few more examples. Part C. Let's take a look at what happens if, so one of the slightly simplifying thing that I did with part A and B, notice the coefficient of x was not only an even integer, but positive. So let's see what happens if I change that, so like x squared minus 3x plus 2. It's negative and it's not an even integer. What happens here is, again, it's going to be a very similar story, but let's see, so solution for part C, f of x equals x squared minus 3x plus, I'm still going to take the coefficient of x divided by 2 squared minus the same number, and then add 2. It's still going to factor as a perfect square, where the number that goes here is the number that's right here. So this will factor as x minus 3/2. And then to evaluate on the end, I've got the square of negative 3 over 2, which would give me negative 9/4 plus 2. And finally, you would have x minus 3 over 2 squared. 2, if I put that, I have a 4 in the denominator, put a 4 on top, so this would be 8 quarters, and negative 9 quarters plus 8 quarters would be minus 1 quarter. So one thing to keep in mind when you have a negative coefficient of x, this negative, make sure you put it in this spot here and in this spot here. Make sure you put that negative 3 in there. When you evaluate this, you are going to square that, so it's going to become positive. So that doesn't really make a big difference if you forgot it here, although it's still wrong. You do want to make sure you put it here to remind you that this has to be a negative. Even though you are going to square this number, remember that when I multiply this out, I still have to get a negative there. So there's a quick check. If I put a positive here and I was to FOIL that out, I would not get a negative in the coefficient of x. All right. Last thing that I want to take a look at is what happens if the number in front of x squared is not a 1. So notice the coefficient here is a 1, coefficient here is a 1, coefficient here is a 1. Completing the square will only work if the leading coefficient is a 1. Therefore, let's see what happens if it's not. All right, that was part step C, so part D. All right, f of x is equal to negative 3x squared plus 5x plus 2. Solution for part D. I mentioned that completing the square only works if the leading coefficient is a 1. Therefore, I have to manipulate this expression so that the leading coefficient is just a 1. That means that this negative 3 has to get moved somewhere. Since I'm not dealing with an equation, I'm dealing with just a single expression, the only way to get this out of there is to factor it out. And so when I factor that out, before I write the rest of the terms, if I write this as a product on the outside, so I multiply this whole thing by negative 3, that means I also have to divide all of these by negative 3. That means I will take, so if I have 5x, so as an intermediate step, I would divide that by negative 3. And then for the plus 2 here, I would divide that by negative 3. Let's just do that. Let's just verify that this works. If I distribute negative 3 back through, the first term I'd have negative 3x squared. There's that. Negative 3 times this term, the negative 3's cancel, giving me a 5x. Multiply this term by negative 3, they'll cancel, giving me just a positive 2. All right, so now let's clean that up a little bit. So this gives me negative 3 times x squared minus 5/3 x minus 2/3. Then what we're going to do is we are going to complete the square inside the brackets, where the leading coefficient is a 1. This will give me x squared minus 5/3 x plus, remember it's going to be something over 2 squared minus the same thing. A little bit out of room here. Minus 2/3. All right. This is your coefficient of x, and therefore that goes on top here, giving me negative 5/3 over 2. All right, next step. I can go straight to factoring this. First and foremost, it's negative, so I'm going to put a negative here. Well, what's this going to be? Half of 5/3. If I flip and multiply 5/3 times, think of 2 as 2 over 1, so that would make it 1 over 2. That would give you 5 over 6. And then here you would have inside the parentheses, you'd have negative 5 over 6. If I square that, that would give me 25 over 36. And it's going to be negative because I've got a negative out front, and then minus 2/3. Common denominator between those two would be 36. So I've got 25 over 36 minus, if I put 36 on the bottom, in other words 3, I had to multiply that by 12. So that means I have to multiply the top by 12, so 2 and 12 will give you a 24. And that would give me negative 3 times x minus 5 over 6 squared, and then minus 49 over 36. Hopefully that's still on screen. Oh yeah, we're good. And then for the last step, we're done completing the square. So inside the square brackets, we've completed the square, we've finished the technique, but the last thing I have to do is when I factor that minus 3 out, I then have to redistribute it back through. So I've got one last step. Take make that -3, distribute it back through, and then we're done. Okay, -3 times this squared term here, I'll just put a -3 out front, and then -3 times this fraction here, minus makes that a positive, and I've got 3 over 36, which reduced to a 12 in the denominator, giving me this expression right here. Keep in mind that function is identical to this one. Those are the exact same function. This is the general form, and this is the standard